Hello and welcome to our webinar about the challenges and solutions for the distribution grid of tomorrow. My name is Oliver Deutschle. I'm Managing Director of SMIGHT, and I have some relevant experience in power grids. I worked for over 20 years for large grid operators in the protection department, in the network planning department, and I was head of the operations department. And today I bring with the SMIGHT team smart grid solutions to grid operators all over Europe. And with me is Dirk.
Right, I'm Dirk Tahar. I'm our International Business Development Manager, and I'm responsible for bringing SMIGHT out beyond the borders of Germany to the rest of the world. And that's why we want to bring you this English presentation today. So we're going to be covering three main topics today. First of all, we really want to depict the challenge faced by grid operators in the energy transition. Then we want to show why we think that smart grids are the way that we need to solve that solution, and how SMIGHT can provide a smart grid solution for the low voltage networks that we have out there in the world today. So to start off with, we want to really get across this idea of what is the challenge, what's the nature of the problem that grid operators are facing today. And so we're going to do that with a couple of stories, one telling you how the future could look if we don't act now, and one showing if we do act now in the right ways, how things can turn out really quite okay. So Ollie's going to kick off with one of our first stories.
Yeah, and this story was told by a CEO of a large network, of a German network operator, and he told me he has trouble sleeping at night because he imagines the following scene. He is worried that the energy transition will put a very heavy burden on his grid very quickly, and he's afraid that a fuse will blow somewhere, and he knows if it happens, he has no idea where the next fuse will blow, and he has acted too late. And he told me this story you see here on the screen. A grid worker enters a substation early in the morning. It's still dark outside, and he does some inspection in the station. So he checks the fuses with his torch. Suddenly, there is a loud bang, and the lights go out. The worker is scared and falls and drops his lamp, and he steps out into the street and looks down the street, and everything is dark. People come out of their houses with the light of their cell phone cameras, and the crowd of people is approaching him. So this CEO, he replied to me, if this scene would actually occur, what he would do. And he said, you can't just push the fuse back in, because first you have to know the cause, then reduce the load on the customer side, then put the fuse back in, and then finally make sure that customers no longer receive high load at the same time. But that will not work in practice. So he has to make sure that his company does not get in touch such a bad situation.
I'm sure any DSO watching today can sympathize with that scenario, this idea that the energy transition hits your network in some critical form, and then you're just left firefighting, having to deal with very difficult issues. So now let's look at how an alternative scenario could look. So here I want you to imagine it's a few years in the future. It's February 2026. The Winter Olympics are happening in northern Italy, and a few things are coming together at one time. First of all, the ice hockey league that's happening in the Winter Olympics, the Italian team has got through to the final, and they're the underdogs. It's been full of controversy all the way through the Olympics until now. It's captured the nation's imagination, and everybody's going to be watching the game tonight. A huge cold weather front has also swept across Europe. And at the same time, over the last few years, the Green parties in many countries have made massive progress on rolling out EV charging, heat pumps, and so on. And so we have this perfect storm situation. We're going to have the heat pumps running at full blast. We're going to have people coming home at the same time with their EVs charging. And everybody's going to be at home consuming power, cooking the kettle or whatever they're doing. And with all of that comes this massive peak load. And so our fictitious character here wants to go out to the substation and see what happens. So he goes out to the substation. It's about half an hour before the game. He opens the door and he walks in. And he knows out there the loads are steadily increasing. And so what does he do? He stands and he listens. And what does he hear? He hears absolutely nothing. Just the comforting hum of the transformer doing its job. What he can't hear, and what's actually happening in the background, is the SMIGHT sensors have recognized the load increase and sent a signal out to all the loads on the network. And all those loads are reducing down to a level where they're still usable. So the heat pumps are still producing heat, but just not at full power. The EV chargers are charging, just not at full power. And all the lights stay on. Everybody can watch the match. Everybody is happy. And so our character can come out of the substation feeling very happy that they took the right actions early enough. These are two rather fictitious scenarios, but I think we get the message across. If we wait too late in the energy transition and act too late, we really are in a very difficult situation. Whereas if we act now, we can stay ahead of the energy transition and ensure that we have stable grids.
Okay, perfect. Thank you very much, Dirk, that things can end positive.
Yeah.
But where are we headed in general? Which great dilemma do we face?
Yeah. So as we see it, grids are really facing a very difficult dilemma. On the one side, society requires of them that they enable the energy transition. But on the other side, society also requires that grids remain stable, that we have power. We can just flip a switch at any time and have the power that we need. And these two things are in conflict because without the energy, if the energy transition is too fast, grid stability will go down. And likewise, if we prioritize grid stability, the energy transition won't happen. And so society requires that the grid operators maintain this balancing act. And it is a difficult balancing act.
Okay, and what do grid operators do to face this dilemma?